Hi, good morning everyone, and welcome to Azure Integration Day. This is an initiative of Microsoft Azure developer community supported by Microsoft Azure and executed by Reskill. So, Azure Integration Day is a dedicated event designed to explore the power of seamless integration on Microsoft Azure. This event is a unique opportunity to delve into the world of integration and discover how Azure services can elevate your organization's digital capabilities with Choreo. Choreo is an innovative service orchestration platform designed to simplify and streamline the management of microservices interactions. It empowers organizations to choreograph and coordinate their microservices seamlessly, enabling the creation of complex and powerful applications with ease. So let's start with the first session for the day. Today we have with us Mr. Naveen Kumar SP. He is the technical advisor at Kongsberg Digital, and he will be speaking about creating and managing AKS clusters. Hi, Naveen.
Hi, uh, thanks for inviting me, and good morning to everyone.
So over to you, Naveen.
Sure. Let me share my screen. Um, okay, so I have to let me share the whole computer. Uh, Let me know if you're able to see my screen.
Yes, now we are.
All right, let me put it in present mode. Okay, very good morning. Thanks for joining. So I have a deep experience in Kubernetes and AKS. Today I will actually go through all the insights what I have with respect to Azure Kubernetes. Just a moment, I have to see how I get the slideshow running. Is it running? Okay, from beginning. There you go. Sorry. Yeah. So Azure Kubernetes is actually a managed Kubernetes. Today, what we will be going through is actually what is this a little quick overview of what is Kubernetes. In case if somebody who is very pretty new to Kubernetes, they can just get a gist of what it is all about, and then we'll see what exactly Azure Kubernetes is. What is it actually bringing into the table? How it actually more beneficial than hosting your own Kubernetes cluster, and some of the salient features of Azure Kubernetes. And later we will start creating the Kubernetes, configure it and upgrade it and manage it. Okay, these are the few things we are going to look at it. So over the period of time, if you look at 15 years back, you had like big beefier servers which were running applications, and then later there was a technology came in called as virtualization, where you virtualize the physical hardware and start creating virtual machines which will have emulated or simulated hardwares mounted into them, where the operating system would not even know that it's running on a uh, virtual environment. So but still the problem was that it still used to have that OS on which you have to have certain tools and utilities. On top of it, you have to have libraries and framework to run your application, and which is much of an overhead. To overcome that, the containerization actually came into picture. So in here what happens is that you will have a teeny tiny footprint. There is no dependency on the hardware, so it is portable. Basically, you can create a container image, you can run it in any platform like Windows, Linux, Mac, etc. And there was no architectural orientation either, so that was pretty good for everyone. And the container adaptation was widely shot almost 10 years ago, when in 2020, 2013, I assume. So this is where, although Docker container was predominantly useful in development, but later there was a question that how do you make it it's highly available, how do you make it resilient, and how do you bring in some of the aspects of application lifecycle management, which includes deployment, managing the availability of the service, and so on. And this is why the orchestration platform came in, which is actually Kubernetes. So basically, Kubernetes is a production grade container orchestration platform. Initially, it was developed and maintained in Google, called as Bog system, and later they open sourced it about 10 years ago. And they started with 1 point not 1 to 8 years ago. So they made a first production grade version at 1.0.1 in July 2015. Ever since that, you are getting releases every quarter from Kubernetes community. And recently, I mean, some time ago, it was even donated to Cloud Native Foundation, CNCF. So that is currently is managing and maintaining it. Now anything and everything is kind of made tailor built to deploy on Kubernetes. In fact, there is a say that it is the cloud OS, which almost every cloud platform offers, and also most of the organizations uses. So why Kubernetes? It decouples the infrastructure, it handles the scaling, high availability, and also it will help you to seamlessly deploy the application, etc. So the major components of Kubernetes consist of control plane, which is where you will have some of the key components to operate the container orchestration platform, like etcd, control manager, scheduler, kube api, etc. And then you have the worker nodes. That's where your containers will be running something called as pod, and there will be certain components running in each of these VMs, sorry, nodes, where you it will help you to orchestrate properly and integrate it as a big cluster. So now coming to the Azure Kubernetes. See, Azure Kubernetes is actually a managed Kubernetes service, which will let you manage Kubernetes cluster in Azure, and yet it will be able to integrate seamlessly with some of the Azure resources like disks, monitoring, logging, and in many other Azure native services. So, so basically, Azure AKS is, since it's a managed service, the control plane, which is where the heart and soul of the Kubernetes cluster, is maintained and managed by the AKS or the Azure itself. So you don't have to worry about the heavy lifting of keeping up the availability of it or configuring it, safeguarding it. Everything is managed by AKS, sorry, Azure platform, where all you will be doing is you'll be creating nodes or the worker nodes, so that is which is required, and you will run your workloads onto them. So you have a certain interface to configure your Kubernetes on AKS and customize it for your requirement. In case if you want to enable certain configuration of properties, you were made certain platform available to you to configure or customize it, but you will not have certain access, such as you cannot take a backup of the HCD running out there. There are certain accesses are being restricted. Although you have API servers, you can't customize it heavily. um, so this is what as it actually becomes a managed service platform, so where the cluster master node or the control plane is managed by Azure, whereas we just manage the Kubernetes cluster, especially the administration and operating part of it, including the nodes that you are going to use. Now, what are the features? So you have, it will provide you identity and access control. So you might be using already Azure AD, or some other integrations you have. You can actually seamlessly integrate it with the Azure Kubernetes, where you could use even Azure Active Directory based logon. You can even leverage the Kubernetes airbags, which is like cluster admin, or you can even specifically grant access to a specific namespace in Kubernetes, etc. And obviously you can even restrict the traffic going in and out of the cluster. And also you, it will help you to seamlessly perform the upgrades without taking much of an effort. If you look at any plain vanilla Kubernetes, you have to have the responsibility of operating and upgrading these clusters, or even patching the operating system running this. By the way, every worker node is will be running a container runtime. Either it can be like Docker, or it can be container D, or any other container runtime. But mostly in Azure Kubernetes, it is actually container D, which is available. And again, this AKS also is regulatory compliant, including SOC, ISO, and PCI DSS compliance. And also it has certain security profiles like SecOps and AppArmor, which would prevent somebody is exploiting the vulnerabilities from OS level or accessing the cluster. And it's a free solution from Azure. You don't have to pay any extra amount other than the resources that you're going to use, such as the worker nodes or the VMs, which where you're running the workloads, and also storage disks and load balancers. Apart from these, recently they have made a little pricing change. They also bought in SLA into their control plane. So they have 99 and 99.9% SLAs. So thus will actually the free tier and standard tiers. The standard tier is actually they're going to slightly small amount for it to keep the high availability of the APIs. So one important thing I don't have it in the slides, is actually that AKS is region dependent. So you can deploy only one cluster only on a specific region. I mean, you can deploy many clusters in a region, but you cannot host a cluster across two different regions. That's not possible. So even if the DNS, if you see the API, right? So basically, since it's a managed service, when you create a cluster, it gives you a DNS with a certain suffix, which is also embedded with the region name where it is being hosted. And again, it gives you certain out of the box platforms or tools features to integrate it with the Azure native platforms, such as Azure Monitor, logging, so that you don't have to worry about configuring and managing the logging and monitoring platform. And also you'll be able to leverage Azure disks and files as the native um, the CSI cloud storage interface drivers. And you could also have a capability of deploying and managing or configuring Azure Blob as the file system for your workload which you are going to run as pod. You might be wondering, why do we need Blob? Although I don't see it out of the box, what is the scenario you would actually need Blob? It's mainly because sometime you may have to take some large data backup, or maybe you need a cheap storage to store some data and it's very huge in size. In such cases, you could actually mount the Blob as a file system to a pod and dump the data out there. Especially useful when you want to take some backup and store it in some Blob. You can actually leverage this option. So creating cluster, so you have a couple of ways. One is obviously the UI. I'm going to walk you through step by step how to create a cluster. Other than that, you could also create a cluster using CLI, both the Cloud Shell, or you could even use your workstation or laptop, where you just have to install Azure CLI and log into your subscription. Other than that, you also have infrastructure as code, template driven approach, like you can use ARM, Terraform, Pulumi. They also can do the deployment and maintain the state. In fact, they are quite capable of even upgrading the nodes or clusters as it needed. Before we start creating, let's understand a bit about what is the networking. So in networking, you have two types of networking. By default, it is actually KubeNet. So what happens is that when you deploy a cluster, when you select a network, so what it's going to do is it is going to get some IP address from the virtual network which you have selected while creating, as the and it will allocate it to the node, and it creates its own internal virtual network of its own, where the pods will be allocated with those internal network. So every traffic which is going in and out of pod will be going through the node, where the network address translation or natting is done, where the traffic will be actually natted and gets the node IP address through which it will go through the Azure virtual network, and it moves to either to external network or even to some other node where some other pod is hosted. This is how the networking works in kubenet. Very economical. You don't have to spend too much of IP addresses. In a organization, what happens is that their entire stack will be running with only few IP address space, probably close to 2000 or 4000 IPs. But with kubenet you could actually just yet more use some more IPs, which will be like, say you are hosting a 10 node cluster, then it will be just a 10 IP more and more IP addresses. But there is another option called a CNI, which is Azure Container Network Interface. So this is where what happens is each pod running on the Kubernetes cluster will be allocated with an IP address of Azure Virtual Network, which is you are actually owning and managing. The advantage is that your pod can access any resources over the network, even though it is not part of the cluster. Say, suppose you have a managed database hosted on Azure platform like Azure Postgres, or maybe you're using Azure Redis. You could actually connect to that straight away from the pod. You don't have to make any traffic, or you don't have to go through the internet to access them. So including any internal resources that you're hosting, which is not part of the AKS, can also access through the CNI. But here is the catch: when you run or configure a CNI, it is basically that since every pod needs an IP to be allocated, it consumes a lot of IP addresses. So when you're creating a cluster, you have to be prepared what kind of network you would need, either kubenet or CNI, because there is no going back. Once you create, you can't switch over. So it's very important that you plan it ahead what to use. Then when it comes to CNI, they have two options. One is static and dynamic allocation. Dynamic allocation is fairly new, but static allocation has been there for quite some time. And in CNI, what happens is that see, Kubernetes has a property where you can define the max number of pods to be allocated, which is at max will be 110 pods per node. So let's say you are actually configuring that while creating a cluster or a node pool. I'll talk about node pool slightly later, but while you're creating the nodes basically to run the pods, what will happen is that, let's say you allocated 30 IPs, saying like 30 containers I would like to run on a node. So that basically implies, so the Kubernetes cluster would need 31 IPs for that node, one for the node and 30 for the containers, which it will reserve upfront. So that means you need a larger network address space to maintain it. In fact, I remember when initially I was actually architecturing a AKS cluster for someone. Well, I went ahead and said I need 4096 IP addresses to create my cluster. uh, the infrastructure architects really jumped at the seat and said, like, wait a minute, my entire infrastructure is not even consuming that much of IPs. Why would you need it? So I had to explain them to make them understand what's the advantage of using CNI, because you will have greater control over it, including you can implement user defined routing and configure a firewall to make sure that you can control the traffic going in and out of the AKS. Okay, so let's have a quick demo. I'm going to step out of the uh, so I'm going to create a new cluster now. So here is the Azure Kubernetes, and in here, so I'm going to click on create new cluster. See, you even have other options like Azure Arc, which is meant for hosting your own on-premises Kubernetes, but maintained by the Azure. But typically, we end up creating, as we mostly are working on cloud platforms of late. We know this majorly. This session focuses on the cloud-based Kubernetes. So now I'm going to actually set up a new resource group. Let's say I'll just create a test AKS demo. So you have a couple of options here, whether what kind of this is more of a preset. You can customize it. You can even pick if you need a production enterprise or production standard, etc. Which actually customize the rest of the configurations here. Let's say when I change this to production enterprise, the VM types and everything changes here. So let's just go for dev test here. So I'm going to give that, I'll give a name, and I'm going to select a specific location. Let's say I'm going to use India. So I'll go ahead and create it in South India. Um, so availability zone is not available for this location, but in some places they even have this, like say, so let's say if you are going for West Europe, you have an option to even host that in a specific availability zone. Like you can select how many AZs you would like to use to host this. So let's just go with India now, as it's near to me. That's why. Uh, Here, this is what I was talking about. This will give you availability of the APIs with specific reliability. Since it's just a demo cluster, I'm going with a specific version which is free tier. See, I'm picking the default version. I'll talk about this later when we are doing the upgrades. And again, you have this automatic patch upgrade. So here, basically, in AKS, you have an option to automatically upgrade the AKS versions, so you don't have to worry about it, or you could even manually disable it so that you have a full control over when you would like to upgrade this. So I'm going to disable it because I'm going to show you how to upgrade this manually. So you could even define whether you want to use AD based authentication, or do you want to would you want to use the Kubernetes RBAC. So when you are going AD based authentication, you have to use kube login. Basically, when you're trying to run a kubectl command on your machine, it will ask you to log in to Azure portal with the device code. Or then only you will be authenticated to run the commands. And typically, this OAuth lasts long for almost a day. And next time when you log in, it will prompt you to log in again. That's more of a secure way of accessing it, but I'll show you how to actually generate the kube config and say it. For our convenience, let's just go with the local account now. And okay, I missed sorry, I hit the wrong button because we have to see the other customizations. um, just a moment, please. So basically, the next section is node pool. This is where you can define what kind of node you would like to use. So if you look at the node pool, so it will show you how much, what should be the node size, and you need to select what kind of machine you would need. Do you need a specific system type, and what should be the size of it? Or would you want to set up the auto scale? What's the minimum and maximum count for it? And basically you have two types called as in node pools. It's basically a collection of nodes put together. So you have to have at least one system node pool, and you can have multiple user node pools. Also you can create multiple system node pools as well. But one system node pool is essential, which will host some of the critical components of your Azure. So I'm going to just going to create a single node pool with the system mode. So you could even define what should be the encryption of the OS disk. You can use your own encryption if you want it. Oops, I'm hitting the wrong button. Sorry. So in networking, you have an option whether to you would you want to choose CNI or KubeNet. So this is where if it is CNI, you have to select the appropriate network address range. Um, See, if you are KubeNet, it's going to manage everything. See, if you select the CNI, you need to actually select the rest of the components, like um, what is the network IP address range and so on. So why is it not? And this enable private cluster is basically the entire traffic, including the API, is exposed to internal, which has certain configuration you have to do, including private zone forwarding had to be done. It will be a little tricky, but it's quite secure. In some of the places, they do use the private AKS if needed, if they have a requirement. They could even define, in case if you are hosting behind the firewall, you can define the the IP, the public IP from which the traffic goes toward the internet, to whitelist the traffic, the sources from which this API access will be done. So that will be helpful when you are actually when you want to prevent the traffic coming from some unauthorized locations or some suspicious locations. So for our convenience, let's just go with kubenet for now. So in integration, you can define if you have any container registry you want to integrate, or you want to configure some of the setup, including default monitoring, or you would want to send the logging and so on. And also Azure policy is basically gateway gatekeeper based policies, which will help you to define certain policies across different clusters and apply to them and get to know what kind of get to know what kind of configuration is not compliant and so on. And you can even define see, basically every cluster which you create will have its own resource group. That's where it creates all the disks and load balancers which are being created for the Kubernetes or the AKS, and it stores it. The naming convention is MC underscore, followed by the name of the cluster, followed by the resource group name where the cluster is deployed. This is how the naming convention will be. If you look at the networking, now I don't need this integration advanced. So I'm going to actually enable secret. This is basically to enable seamless access to the key vault. This will help you in case if you have certain secrets you would like to directly pull from key vault, you could actually configure that. And tags, you can add it. It's as usual of any other Azure resources. And now you will go ahead and actually create the cluster. Just a moment. Okay, now some validation issue is there. It says that this file size, the VM size is not available in South India. So now I need to go and change the node pool type. So I'm going to change this now. I will change. It will show you the available node pool size. So you need to pick and choose the node pool as required. And please keep in mind, if you are hosting a lot of persistent volumes based Kubernetes workloads, say you are mounting a lot of PVs into your pod, that basically indicates that uh, you need to select a smaller size node with multiple nodes, because there is an VMSS limitation. Basically these node pools are nothing but VMSS. Those VMSS will only allow you to mount only up to 15 uh, disks. So that implies you cannot host more than 15 pods in a given node. So that means you have to size it properly as it needed. So I'm going to change the location. Looks like they don't have some of the um, so I'll host it in central India itself. So that's why the sizing of the VM is also important. So you have to keep in mind. And again, depending on the workload that you're running, let's say you're running a lot of memory intensive application, then you might have to think about hosting it on a a memory intensive E series VM size, or rather than D series, which is generic. You have to think and design, and there is nothing wrong. Even if you have chosen the wrong node pool, you can easily replace, including the system node pool can be replaced easily. You can have multiple node pools. We'll talk about that slightly later. So I'm going to go ahead and create this AKS cluster. So in fact, I'm not going to create this from here. I'm going to show it how do I create it from CLI. But I have a cluster which I already created. Here is how it looks like. So you can see this. I've just created a demo cluster, and it is hosted on 1.26. And you can notice that it's already hosted in central India. That's why you have the region defined here, and this is the prefix which starts from here, DNS, whatever the number you are seeing, which has certain naming convention, which is central India, which is our region. .azmk8, that's the domain where our APIs are hosted, and this will be publicly available. And you also have certain options to configure your setup. such as what is the APIs, what is the API tier, is it free tier or a standard tier, and do you want to change the authentication methodology, or in case if you would like to upgrade the Kubernetes version, you have the options to do so from here. Like you can just select the version. Since it's already automatic upgrade is enabled, so it will not let me. I have to disable it and then decide how to upgrade this. We'll come to this little later. And going back to the cluster, again you have you'll be able to see the networking, basically what kind of networking has been configured and so on, and also the what should the network policy, the network plugin which is used inside the cluster. And also there are many more properties. We will look into that slightly later. Let's just show you how to create the cluster in CLI, and then we'll go ahead from there. Okay, so just a moment, I'll just so I have actually logged into my account. Okay, see, here is my login. So I've logged into the MSDN. So I'm going to actually create a resource group. So I'm going to create a resource group, say so I'm going to give that Central India. So I'm going to create so let me just formulate the CLI before I paste it here. So the resource group is Central India RG, Reskill RG. So this, let me just say, I will make it as Reskill demo. And I'm going to set up the managed identity. Node count as one basically implies that I'm creating a single node um, cluster. That's also possible in case if you want to run it and you want to add certain add-ons or something, you can set it up. So I'm going to actually make it as row count 3 just for easier purpose. I'm not going to set up anything. So with this simpler command, you could actually even create a cluster. So it picks up some of the defaults such as the network as kubenet, and any other additional settings. It will actually pick it based on the default property of that AZ AKS create. So let me just pull that the documentation. So similar to this, you could also use Terraform based if you look at the resource provider which is Terraform, if you see the resource block of Azure uh, Azure RM Kubernetes cluster, if you look at the example here, so all they're doing is creating a resource group and creating a cluster with certain inputs into it, like what kind of VM node pool should be, what is the identity, and so on. And also you can pass all those arguments from here, like what's the location, node pool size, how it should be, and would you want to integrate any containers into it, or set up some configurations, including where do you want to send the traffic and so on. So here is where my cluster is being created now. I'm running a 3-node cluster called as Reskill demo, and Reskill RG is the resource group. So let me just show you out here in the resource group section. So I have this Reskill RG here, and under which the AKS is being created. You could also know that it is also creating another resource group called as MC underscore reskill hyphen RG, which is the resource group name and the name of the cluster and the location of it. Similar to that, here is the other one which I just showed you, which is AKS demo, where I have created a cluster, and these are all the underneath components such as node pool, which is nothing but a VMSS, or the network which was created using for the kubenet, and also any other configurations related to it is configured here. Even if you have created a Kubernetes workload with a load balancer, it will create a resource out here associated with it. You might be wondering how it all happening, right? So that is where you have something called as uh, cloud resource provider, I think, the cloud controller in the core components of Kubernetes, which will be responsible for talking to the uh, which will be talking to the cloud resources and creating it. um, Going back to the slides, so we just saw how the AKS being created. Now moving on to the next topic is actually, sorry, starting from beginning. Oops. Okay. So the next part is actually upgrading the cluster. So now, now that we have an understanding how to create a cluster, let's see what is the model or the strategy what you have to follow in terms of AKS for Kubernetes upgrades. So basically Kubernetes releases a minor version every quarter, and AKS also keeps up with these version upgrades, and they typically be a one version behind the latest version of Kubernetes. And it can, I guess, cluster upgrades can be either manually, where you have full control over it, where I could also even put it on automatic mode. I will talk about manual first before I explain how does the automatic works. So even they have a support metrics where it say that when till when they are going to maintain the Kubernetes versions, and typically they support n-3 version from the current latest version of AKS, or the general availability version of AKS. And after that, if you run into issues, typically Microsoft or Azure recommends you to upgrade the cluster before you even raise a support ticket with them. Then when you're doing manual upgrade, it's optimal for testing latest version of Kubernetes, in case if you want to test your workloads on a new version of the kube, or you want to have a full control over it. In such cases, you can opt that. If you have even a strategy that I won't want to run the I don't want to retain the existing node, rather I want to have a separate nodes for the existing workloads, you could actually do the manual upgrades. In order to upgrade, you have two commands. One is az aks get upgrades. Basically, it will show you all the available upgrades for your cluster. And uh, when you're in order to upgrade your cluster, you need to run a command az aks upgrade command followed by the version and so on. And also you have certain, again, I'm taking a detour. So here is the documentation where they've kept up to date what is the current version of Azure Kubernetes till when it is available, and what is the end of life date, and what is the recommended um, Azure Kubernetes to be opted, and what are all the latest versions which are available. Although if you see the latest Kubernetes version, so I think it is 1.30 is already here. But it is not something they, sorry, it is 1.28 is the latest, my bad. But if you look at it, although they have 1.28 and 29, I mean, they have 1.28, I assume. Let's just see that, because these are all constantly being changed, or there are a lot of enhancements have been made of late. But if you notice it here, you'll be able to see what are all the available versions while creating it. So not while creating, you have to see it, because while you're upgrading, it will only allow you to upgrade to the next subsequent version. But while you're creating, you will have the option which version you would like to choose in Kubernetes. Yeah, you have even 128, but it's in preview mode. But like I said, it will be specifically one minor version behind the latest version, which is 1.27 is the supported version which they offer. Now, automatic upgrade. See, now it's quite cumbersome to manage these upgrades, keeping up with this, because every quarter you have a new version release and so on. It will be a little tedious to maintain, call out for a maintenance. If you're Since this cluster should be seamless platform where it can migrate the workload from one node to another easily without any interruptions, provided your application has the capability to take a small downtime in merely few seconds, then you could actually opt for automated upgrades. In here, what you have to do is, you need to set up the upgrade type as automatic when you are configuring it. I'm going to actually define one of them as manual to show how manual upgrades are done. Yeah, so when you're selecting the automatic upgrade, what will happen is that you have to define what kind of channel of upgrade you would like to choose or use. There are a couple of options here. One is the stable version, enable with patch. It basically takes the latest patch versions, but within the minor version, because let's say you have 1.26.6, any patches which is on versions will be automatically upgraded. Any enabled with patches is basically it will patch to the latest minor version or upgrades the cluster to any available minor version. If I configure this, what will happen is that my cluster version will be upgraded to 1.27 automatically, as there is a generally available minor version which is 1.27. When you go for rapid, it actually goes for the latest generally available version. Rapid and stable is basically that even the patch version in there is actually the difference. And when you are enabled with node image, is basically updates the operating system as well, but does not update it just patches the nodes or the operating system, but not the Kubernetes version. When you mark it as disabled, you have a full control over your setup, like what you would like to do. So I'm going to change the upgrade type as actually a manual, because I would like to show you how it will be done manually. Okay. Now, these are the different channels, and it's the explanation why do we have that. I will talk about, I'll show you the demo slightly later. Let this configuration update. It'll take a small moment. So while it's happening, let's just look at the other properties. Oops. Okay, I have messed up my, oh no, it's here. So let's look at the accessing the AKS cluster. So AKS cluster can be accessed using UI, like you are seeing. Some of these configurations are will be visible to you if and only if you have privileges to this cluster. If not, it will not show you out here. It depends on your RBAC configuration that you have done. So else it will say that you do not have a permission to take a look at this also. When you have even in access control, you have a couple of options which includes different types of roles like custom administrators and so on. You could also create your own custom roles and assign it. But um, since I'm using Kubernetes RBAC, not the user RBAC, sorry, the AD based RBAC, um, it'll be tough. But you can see that there are a lot of roles with explanation what it can be capable of, which includes AKS cluster admin, cluster monitor, user reader role, and also the cluster inside the cluster you will have permissions. There is a significant difference. When you have cluster admin, you have permissions here too, whereas you are a Kubernetes admin, all you will have admin access inside the cluster as an admin, not outside properties of the cluster or the AKS. So there are a couple of different roles available to assign based on the user requirement. You can actually pick and assign them. Okay. Now, in order to access it, there are a lot of options. One is the UI, where you'll be able to see the workloads, all the storages, services, and so on. And you could also run some command on the fly from here. The other approach is using the Azure CLI or Azure Cloud Shell or even the Azure CLI. So now you can see, okay, here is the newly created cluster with the output, how it got created, what all the properties it has been assumed, and so on will be listed here. And you can see that I could also even run namespaces. If you run this command, it will get you the output. So it is going to show me the command, and it will show you the output out here. You will be able to see the output right in the console itself. This will be a quite easy way to just quickly run some commands to get to see how is that happening, etc. And, but it actually runs through a AKS command namespace. That's where it runs the CL commands and get that, So going back to the slide, you have even Cloud Shell, which is same as Azure CLI. So what I'm going to do is I just created a new cluster, right? So I'm going to collect the credentials of it or the kubeconfig file from here. In order to do so, if you click on this connect button on the overview page, that will show you um, the instruction on how to set it up. So I'm going to run this command az aks get credentials, which will download the kubeconfig file and merge it with my local kubeconfig. Okay, so other than that, there are even different options. You could even manage the AKS cluster through Rancher Server or any other cluster platform management platform like Portainer, or even Red Hat cluster management service, or some services there where you could actually manage third-party clusters as well. You even have some other tools like Lens, which is an IDE for Kubernetes, where you'll be able to select the so here is where you can see that it has pulled the kubeconfig file, and if you have opened it, you'll be able to see the cluster which is listed in the Lens. Or you could even run a command in here itself, like kubectl get config get context. So you'll be able to see all the available kube configurations available in the kubeconfig file, or the clusters and the context which you can actually use or access. So here I've just accessed the same in the uh, Lens as well, where you'll be able to access and configure or interface with the cluster using an IDE called Lens. You also have some other options like K9s, which is actually a CLI based Kubernetes utility, where you could even use like you could actually set up lookup for the you can actually access the cluster, configure it. So you'll be able to see all the config maps or secrets. It has its own interface. This will be useful, especially when you are accessing the cluster from some jump host where it's a Linux where you need to access it. This will be pretty good to rather than typing up the commands and so on. It'll make your life easy. Going back to the slide again. Excuse me. Going back to the slides. So we looked at, let's look at two different concepts, which is, oops. So I have some hard time managing this slide. So I'll just go with the simple interface. Okay, sorry about that. Yeah, the next is actually add-ons and extensions. See, there are two important types called as add-ons and extensions. Add-ons are actually fully supported and part of the AKS directly. And you will use AZ AKS enable add-ons command or any other AKS um, verbs to configure the add-on, which are part of the AKS resource provider itself. While creating the AKS, you can configure it and so on. And some of the examples are like monitoring Azure policies and Key Vault, which is the secret CSI provider, Virtual node is very important. Sorry, I missed out to explain this. So it is also possible to run the AKS on a scalable setup, where it will be your node is also another container instance in Azure, which is ACI, where the scale out will be very fast when compared to VMSs, basically because your VM is nothing but another container running on Azure container interface. Okay, ACI. Okay, so that will be very useful when you have to really scale up fast and scale out, or scale in, as it needed. So scale up and scale down, you could use the virtual nodes as an option. It will be available out here. I'll talk about node pool shortly, but I'll show you how to set up this virtual node if needed. Uh, then moving on, extensions are actually ARM driven experience to install and maintain some of the services, part of the AKS cluster, but they are not part of the Azure Kubernetes resource provider. Rather, it's a simple, Azure API. Through which you could run this. It's like, there is a command like Azure, AZ enable extensions, something like that, which will, sorry, AZ extension add. Yeah, here is the command. So this will help you to enable the extensions on your Kubernetes, but they are not part of, you even if you look at the CLI, they are not part of the they are not part of the Azure. Rather, it is based on the Azure API directly, not part of the Azure AKS. Here are some of the examples, like, you can install and configure Grafana, Prometheus, Couchbase, Istio, etc. on the AKS directly through these commands. These two are the setup. I think we are already covering some of these, which is configuring AKS. Yeah, let's talk about the important part is actually node pools. So AKS can also host a single node cluster. I think I just showed you a CLI. You could also even set it up when you are on UI. In case you just want to spin off a cluster for some simple work and you want to destroy it after some time, like a very short time, say 1 or 2 hours, you could straight away create one and destroy it with a single node. But it will be a little risky because something happens to the node, or if you really run some rogue container or pod with bad commands, can seize the cluster. So but in your hosting cluster, it's always recommended to go with odd number of VMs. No, at least you have to have one node, a system node pool, and it can have many user node pools. Basically, a node pool is nothing but a VMSs, which is running where the underlying VMs will be running your applications as pod. And you can basically two types. One is system node pool or user node pool. They are two different types. Typically, system node pools are reserved to run some of the critical application pods like core DNS, metric servers, and so on. You What you'll do is you'll reserve the system node pool only for that, or maybe running some applications which you would want to separate it from user node pool, like logging or ingress or something. You can define that. And then comes you know in order to create it, you will run a command az aks node pool add, and you could, in hyphen hyphen mode, will define what kind of node pool you are creating. Let's go ahead and create a node pool here. When you're creating it, you will be given an option where you would want to use a system or user node pool. And you could also choose, if it is a Windows cluster, you can even pick and choose. See, in order to use Windows cluster, you have to have a CNI based setup. So that's why it's not allowing me to create a kubenet Windows cluster. I'll talk about why do you need a Windows based cluster in a short moment. And you will define what you want to define there, like say prod apps. I can even host multiple environments in the same cluster. That's totally possible. uh you can't have the, okay. So, and you can define what kind of operating system you would like to use. This is something new that they have brought in, which is Azure Linux. Earlier it was only Ubuntu Linux, but they've changed a bit now. Could even define what kind of resiliency you need. Let's say you are hosting 3 nodes. I want to run all 3 of them in different nodes. You can define them so that those nodes will be placed in either any of these nodes which you have selected. Now you can select the node type. You could even opt for a spot instance if you prefer to do so. And let's say I go for B4MS, and I will also go for manual. I don't want it to be more, although it's not a prod category, but I'm just showing. And you could even define how many pods you would like to run in a node. You can define or adjust it. It can even go up to, yeah, by default it is 110. Now it can go up to 100, 250. You could even define in case if you have max surge, like where how much it can go up and down in case there is a scale up or scale in is happening, or whenever you are draining your upgrades. Especially in upgrades this will be useful. If you define that I don't want to lose more than 60% of my node, I can just set it up here, the node counter, so that you don't run into any problems while upgrading the cluster. Although the upgrade happens in a very rolling fashion, I'll explain that shortly. So here is how you could go ahead and add a node pool. So it will take a short moment. Basically what it's going to do is it's going to create a VMSS called as products inside the MC underscore. Okay, I ran out of the resource, my bad. So maybe I have to take a smaller size. Let me choose that. Maybe I'll take a div2. Maybe this will do the trick. Product. Maybe I'll just take a single node setup. That will do the trick. So now it is going to add a new node pool here. It's basically nothing but another additional VMSS will be created and configured and integrated to the cluster automatically. If you see the number of nodes here, let's just look at the nodes from here. If you look at the reskill, you have 3 nodes. It will add an additional node here from the node pool, which is the prod apps node pool, which will be created shortly. So okay, so if you see it here now, you will be seeing the nodes. It will add one more node shortly. All right, so now moving on to the important thing, running Windows container. So this is something very important because you do not have this in any other hosted platforms yet, or they are still in an experimental phase. AKS allows you to run Windows-based nodes to run, also allows you to run Windows container. Windows container support in Kubernetes itself is very recent. In 2018 onwards, they started and they are supporting it. And you might be wondering, why do I have to run Windows container? Typically, you will be running Linux containers, right? So Windows Core is for the traditional .NET applications. Nano Server is for .NET Core apps. Windows for if you are hosting some full-fledged application where the core is missing some of the capability. If you want full support with the GPU acceleration, then you will go for a Windows Server container, which is similar to, which is something similar to your Ubuntu or Alpine containers, but this is all meant to run Windows applications or traditional .NET applications. Okay, I've already shown how to add a new pool. Upgrading, we have already covered it. So I think as the upgrades are, I'll show you upgrade shortly, but do you have any questions as we are almost reaching to the closing the 1 hour? So now you can see that it has just added an additional node pool, which is called as node pool 1. If you run the command, it will be adding another node soon, or his product pool is not ready yet, it is being ready. And if you see the resource group, you have this reskill resource group. Here you'll be able to see that it has added another VMS is called prod apps and configured or created the VM for you. And it will be made ready shortly. But when you are creating a cluster with the virtual nodes, what will happen is that it's nothing but containers, and it will scale up and scale down really quick. It will not take more than a few seconds, whereas VMS's based setup will take some time to scale up. So if you see, it just added the new products. VM, which roughly took about 30 to 40 seconds, within a minute basically, where you will have a VM additional load added to this. So in order to upgrade the cluster, so I have not covered that, my bad. So you can run it on both CLI or you can run it both on CLI or user interface. Let me just show you quickly on the user interface. I think in the demo setup, I have actually disabled the automatic upgrade. So let me show you how it will be done. So you have an option either to upgrade the entire cluster altogether. What will happen is it will first upgrade the control plane, and then it will start rolling upgrade the node pools. What will happen is it will upgrade one node, then move on to the next node, and so on, rolling upgrade. If you have given a max surge configuration saying like I am okay to lose two nodes, then it will start upgrading two nodes at a time. So that will make your upgrades quite faster, and try to get the upgrades done quickly. The upgrades will take roughly 15 to 20 minutes at least, and it could go up to 30 minutes depending on the time which it takes to drain the pods from there. Yeah, I think this is where I stop, because I think I covered almost all related to configuring and creating and managing cluster, AKS cluster. Do you guys have any questions? Yeah, sorry, I just noticed the question. Sorry. Can we configure I just noticed it. Okay, my bad. Yeah, can we configure the output connection to services outside the cluster? I mean, what kind of the from the pods to external service like database? Yes, you can definitely configure the pod to access external services. If you have some internal services as part of your virtual network, probably the best option is to use the CNI based network. Else, it will be little disaster. And also, you can incorporate a gateway like STO. Definitely, you have an option for add-on through which you will be able to enable Istio, or you could even manually deploy or configure Istio on top of AKS. That's totally possible. And also, if you've seen, they have this Ingress app gateway. It's basically uses the layer 7 application gateway of Azure to integrate with. Hope that answers your question, Alvaro. Jose. Okay, any other questions you guys have? I think the upgrade is in progress now. You can see once the control plane has been upgraded, you will see it has been changed to 1.27 soon. First the control plane upgrades and then the node upgrades. If you see the nodes in open lens, um, even I can switch the context here. So now the nodes are still 1.26, but let me just show you in command get context. I think it is dash dash version. Yeah, so now you can see that it has already changed to 1.27, but the nodes are still so you can see that the nodes will be still 1.26. It is yet to be upgraded. So now it is doing a rolling upgrade. You can see that it has added an additional node. Now, once this node has become ready, the old node will be removed out of here. And so once the first node is being upgraded, then the new node will be added, and the second node from the previous version will also be removed from here. It does a rolling upgrade. It takes care of the draining and migrating the workloads and all that, and also cordoning and uncordoning. Everything will be done automatically as part of the upgrade process. When you put that in automatic upgrade, so it will take care of it automatically during off business hours and try to get the upgrades done. Yeah, with this I am done with all the things which I would like wanted to share. Do you have any questions?
So I guess there are no questions. Thank you, Naveen, for such an insightful session. It was really great.
You're welcome.
Thank you. So now we have our expert speaker for the next session. So moving on, for the next session, we have Miss C.R. Bhargavi. Bhargavi is a Microsoft certified trainer and she is a senior software engineer at LTI Mindtree. And she'll be talking about serverless computing with Azure Functions and AKS. Hi, Bhargavi.
Hello, are you able to hear me?
Yes, we are.
Okay, thank you. And let me share my screen. Please do let me know if it's visible. With that,
Sure.
let me get started. Is my screen visible?
Yes, it is.
Okay. Uh, Hi all. Thanks for joining today's session. And in today's session, we would be seeing a serverless um, uh, server. What is serverless computing with the Azure functions and AKS? With that, we would be kickstarting with today's session. Um, uh, this is Bhargavi here, and I am a senior software engineer working for Ford. I'm an MTech data scientist from Bechpalani, and I am a Microsoft certified trainer as well. And apart from that, I am a I do hold more than 6 certifications from Microsoft and um, C Sharp Corner MVP as well. And apart from that, I am a global speaker and blogger and author. This is my LinkedIn ID. Please feel free to connect with me for any queries related to Azure or Power Apps post the session as well. And this would be my blogs and blogs related QR. You can scan this and get in touch with the latest update of the blog that I write in. Okay. With that, we would see the agenda for today. We would be covering the overview of the Azure function and what is serverless computing. And apart from that, we would be seeing what are the tools that are needed for that are used under the Azure functions and under the serverless computing as well, and what are some of the common scenarios that are available, and we would be wrapping up the session with an demo on it. So what is serverless? Serverless is like we will be having the abstraction of servers, and it is like it is like we can be thought of a function as a service like FFAS, and with that a microservice can be hosted on a cloud platform. So we have many kind of things like Kubernetes, or we have different kind of things over there, right? So if that's all been there, then we might need a separate things being done for us. But when it comes for Azure functions, that we will not be able to, I mean, we don't have to pay when we are using the we just have to pay for whatever the things that what we are using alone, and we don't have to pay for the whole thing that are left unused. So that's the use of the serverless computing. And you will have a like whenever you trigger an event, you will be having the instance being created for you, and you will have the micro billing being available for you. So this is serverless. And when it comes for serverless scale, you will have a monolith, and with that you can have multiple microservice being created for you. And there can be a nano service being available, like each there can be n number of Azure function or different type of function being inhibited, and you will be able to use that inside the same um, uh, you will be able to use that inside the same thing. There can be n number of functions that you can use inside your uh, inside your process, and you will be able to uh, have the scalability for all those things in place. And what the benefits of serverless is, like you will have the reduced DevOps, and you will be focusing on your business logic, and it will have a faster time to market. So you will be having like you don't have to do the you don't have to pay for whatever the logic that what you have not coded for, and you will be having a um, you will be paying for whatever the things that what you have been using. And when and now Azure function is something which we will be we it works in the serverless computing. And it is something which are event driven, and it will have a demand on experience. And it is something like you will have code plus events and data which are merged together, and you will have that being deployed. I mean, you can use that in various languages like C sharp or node.js or Java. And there can be a number of things that where you can use it, and you can deploy it, and you can use it along with HTML, or you can use it in various things that whatever you need. And Azure function is basically a solution for easily running a small piece of code or functions that are available in cloud. And you can write it is something like you can write the code. You can write just the code you need for a problem at hand, and without carrying the whole application or infrastructure like what we saw earlier, right? It would be providing you as such the infrastructure as a service, and it would just provide you the whole application or infrastructure to run it, and you will be able to use it. So that is where the Azure function lies on. And you will get all the infrastructure and everything, and all you have to do is carry your code alone with you. And what can you do with Azure function is something is like very simple. You can combine it with all with n number of n number of things, like you can integrate it with IoT, or you can integrate it with Event Hub, Cosmos DB, or anything that like you can have a scenario where you will be having a uh, datas inside the blob, uh, and that has to be read, and you have to create a function, like it has to be updated, or it has to be read. Then you would be creating the Azure functions, and you will be making that read from the blob. And it also works in a similar way that it works for the chatbot as well. And it's something like you can integrate with IoT, or you can build simple APIs and integrate it with this. Or you will be having you have different functions, and or image or file maintenance, all these which need some kind of schedule to be run, will be can be carried out with the help of Azure functions. And Azure function basically works in supports triggers, which is like which are the ways to start the execution of your code. It's something which it's it's like the triggers are the events that start your function, and which will help having your data, and that will have the different services being available to you, and that will make the different services that are being available to you, and that can be of HTTP, or trigger, or storage, or that can be of event grid as well. And there are a number of things that are available. And Azure function also has something called as bindings, which are two important things. Like you can call it as Azure function hooks as well. And triggers and bindings are something which are bound together inside the hook. And we saw something for Azure sorry we saw something for the Azure functions, for the triggers, right? So now we would see about the bindings. Bindings is like where you can connect to the another, like they will be it will be used for simplifying the code for input and output data, where you can connect to the another resource, and you will have both the input and output being available for you, and you can have multiple bindings inside the same process. So these are some features that are available inside the Azure functions. And when it comes for when it we have a similar functionality like logic apps. And functions is something which comes in as serverless, right? So what would be the difference between the functions and the logic app is that we would be coding at first when it comes for functions. And we will have built we can have a built-in bindings that are available and used for binding the custom bindings as well. You can write the custom bindings as well, and you will be able to have the you can have the way of various bindings of input and output inside the Azure functions, or when it comes for functions. And whereas in logic apps you can have only certain large collection of connectors, and enterprise integrated pack will be available. And you can build custom connectors, but you will not be able to build as such what you are doing it in functions. And when it comes for action, it is like each activity in is an Azure function by itself, where you will be carrying your code, and you will be performing the activity for each function. And in logic apps, it differs in a way that large collection of all the ready-made actions that are available will be put in together, and that will be coded together. And how do you monitor the functions is that you have application insights that is being available inside the Azure, where the logic apps should be monitored inside the Azure portal under the Azure monitor logs. And when it comes for management, it is like the REST APIs and Visual Studio are being used. And here you have the similar thing, like you have the REST API, PowerShell, Visual Studio, and it is something which runs in cloud. And logic apps is something which run anywhere scenario. So it is like you will be having the way of uh, the difference between the main difference between the function and the logic app is something where you will be carrying over the sorry okay, you will be carrying over the code alone, and with that your different kind of functions and events and data will get triggered at the later stage. And when it comes for Azure function development, it is like a function. A function app is which will provide an execution context in Azure, which will make your functions run, and it is a unit of deployment and manages your function. And it is all about all of the functions inside the function app will have the same pricing plan, and then it will have the same deployment method and the runtime version as well. And you can have the a different way of organizing and collecting and managing your own functions by yourself. And you will be having one or more compromised way of individual functions that are managed and deployed for whatever the need that you are opting for will be scaled together. And uh, it is something like what we can do with the Azure function is like you can process data, or you can integrate different systems. And as we saw, you can integrate it with IoT, and then you can build simple APIs and microservices. And Azure function provides template for large number of key scenarios. And this is something we saw just now, like triggers is something which is used to start the execution, and binding is something which is used for simplifying the code for input and output data. And the integration, when it comes for integration, it is like you have now uh, been there are different supported integration that are available, like Cosmos DB or Event Hub, mobile apps, notification hubs, um, service bus. All there are different kind of things, and where you can connect your blob queues and tables as well, and you will be able to build webhooks where you can connect it with the GitHub and build the webhooks as well. And you can also use it for chatbot, and you will be using it for SMS messages, which is commonly used as Twilio. And then you can have a on premises one, like using the service bus. And then you can have different kind of services that you can trigger, and you will be serving both the input and output for your code, with all these integrations being connected. So the Azure serverless function is now becoming so easier to create all the small targeted microservice architecture that what we want, and it will be used to, it will help you to achieve a high throughput and low cost solution. What you can use here is like Azure Function, Logic Apps, Event Grid are just a few in the serverless architecture family, and you can go ahead and use this. And when it comes for uh, functions, triggers, and binding, it is something like these are the ones which work for trigger, input and output. Binding is like input and output, right? So with that, the input and output is being mentioned here. If it will support the input and output is what it means here. When it comes for HTTP, it supports for the output, and when it comes for blob, it supports both triggers and then input output. So you have to note all these things and make sure that if your requirement will be suitable for getting the trigger or binding, and based on that, if it will support your if that's if that's for binding, then will it support both input and output. So you have to be cautious on using all these things. And if it does not support input, and if you are trying to get an input, then it would not be accepting, and you would be stuck up in some trouble. So you should ensure that you are using these things, and ensure that it is supporting both trigger as well as binding, and that too for appropriate input and output. So where do you develop is that you can develop it inside the Azure portal, or you can develop it inside the Visual Studio 2017 or code, or you can develop it inside the CLI as well. And if with that you can build any kind of function, and you can do edit in the IDE of your own choice. So now let's see some of the scenarios that are available inside the Azure function. We can have a scenario like a timer based processing, where it would support the Azure functions are been supporting an event which will be based on a trigger, which will be based on a timer, and which supports cron job syntax, like it would be finding and cleaning an invalid data. With every 15 minutes, it has to find that invalid data, and it should erase that, and it should provide it in a clean table. So to make that being available, you can use the timer based processing, where you can deploy the where all you need is that you can build the Azure functions which will be finding and cleaning your invalid data, and that can be integrated with the timer, and that can be integrated with another SQL, where it would store just a pure data alone over there. So you can do these things, and this is one of the common scenario that what we are using in the Azure functions. And then this is another real time streaming process, where consider a scenario that you can have a millions of device feed, like you can consider a similar case of Twitter itself. You are trying to transform the streaming data, and you can use you want to connect it with that data, you need to perform some kind of action. For that, what you have to do is that you have to you can power an IoT streaming analytics app, like you will be getting the data um, from the various devices, and with that you get it connected with the Azure functions, and that would be transforming into the structured data, and that structured data will get stored in some database, and from that database you can get in access with your IoT device, or any type of device, that whatever you need. So this is some kind of real time stream processing where you can use your Azure functions. And like what I was trying to explain, you can have the Twitter, one of the famous Kaggle project, right? Twitter streaming data, and what you can do there is that you can create a trigger for it, and you can you can get the data from the Twitter, and it should transform your data into the structured data, and that has to be stored, and you will be having the data being stored inside the Azure SQL data, and from there you can use it for your purpose. And when it comes for real time bot messaging, it will be used for having the messages to your bot as well, where you can create a function, and with that function the chatbot will make a response for your data, like using the webhook it would get connected, and you can you can get an get your chatbot being respond back for you. Now with that we will see a demo for another 2 minutes, and sorry, we will see a demo for here, like how we will be connecting the function app. And sorry that I don't have power in my area, so my laptop is also running out of charge. So let me try to wind up the session as soon as possible, and please do reach out to me in case of any queries post the session as well. I would be able to help you with that. I would just give a gist of a demo, that what I wanted to cover in short. What we would be doing here is that we have something called as, whenever you want to create a function app, you would be coming to portal.azure.com, and go to resources, and with the resources, inside the resources you find something called function app, and you would be creating the function app. And for the creation you need a resource group. A resource group is something which you would be, where all the resources will be grouped together. The different kind of resources will be grouped together, and you can use that to, like, if in case of you need to delete something, or it will be tagged under a name, and you have to use it for different purpose, it would be useful for that. And you would be giving a name, function name. Okay, that should be unique, and you have to ensure that you are giving it unique. And you should select the which kind of version, that what you need to select for, and it should be of Windows, or what kind of operating system that what you need. And if it's a serverless or function app premium, you would be using it. And then you would be creating the application post that with all the things being done. And function app will take around 1 or 2 minutes to get created. Once that is created, go to the resource group, and with that you can access the resource group where you will have the triggers and binding of whatever the things that what we saw just now in the theory part will be available. Let it get created. I would open up and will show you. It is in creating stage. Give me just 2 minutes. Okay, let me go to that particular resource group, and you would find an it is still in the creating stage. Okay, I'm not sure why it is not getting created. Just a second. You should ensure that all these things like enable inside
I guess there's no power at Bhargavi's side, so her laptop died, and we'll have to move on with the session. I guess we'll continue the session with Bhargavi another time. Meanwhile, let me just check for the next session quickly. Sorry for the inconvenience. Just wait for some time and we'll be back soon for the next session. Yeah, sorry, I'm back. And so we'll move on to the next session. And for the next session, we have Mr. Nuan Dias. He's the Vice President and Deputy CTO at WSO2 for Startup. And he'll be talking about building scalable microservices with Choreo on Azure Kubernetes services. Hi, Nuan.
Hi, can you hear me okay?
Yes.
All right, cool. Are we good to get started?
Yes, yes, absolutely. Whenever you ask.
Okay, cool. 1 second. Okay, let me share my screen. All right, can you see the screen as well?
Yep.
Okay, okay, let's get started. Thank you everybody for joining in. So as I was introduced, my name is Nuwan Dias. Let me see why the screen is not loading. All right. So my name is Nuwan Das. I work as a Vice President and Deputy CTO for WSO2. So it's a pleasure to be here. And I'm also the author of a book called Microservices Security in Action. And you can find my LinkedIn and Twitter handle right below on the screen. Um, so if you are interested in getting in touch, I'm more than happy to get in touch with you guys. So basically, what I hope to do today is to talk about Choreo, about basically a platform which helps you build your microservices at scale. And before I begin, so the format of the session is going to be I'll introduce the problem we are trying to solve very quickly with a few slides, and after that I'll directly jump into the product demonstration to show you how the product works in real life. So at WSO2, our mission is basically to help customers create applications very fast and easily. So we follow this rule or believe in this statement called just add developers. So what we believe is, in order to build great experiences, to build great applications, all you should need is developers, right? And of course, it's a bit of an exaggerated statement, but that's fundamentally where we want to get to. And the reason we make that statement is because we figured out over the last 15 16 years of doing business in this space is that building cloud native applications is not a trivial task. It takes a lot of time, it takes a lot of knowledge, it takes a lot of effort into building applications at scale. So there's a lot of time and effort involved in building these applications. Actually, this time is something that businesses should actually invest in building something that's unique and differentiating for their businesses. But instead, we've noticed that there are a lot of time is actually spent on building platforms. So that's a problem we are trying to solve. So if you get into the details a little bit, so what does it take to build a cloud native application and run it at scale, right? So and so if you look at on the left hand side of your screen, we kind of mentioned some of the things that you need to be concerned of and get done in order to get an application. So everything from GitOps to CI/CD, Kubernetes, setting up API gateways, setting up authentication, authorization, observability. So all of these things are needed in order to get an application running on the cloud at scale. While there's technology and services to get these things done, human beings have to be involved to set these all up for you, right? So that's basically what we are trying to automate and streamline as a platform. Basically, with Choreo, we are trying to make it possible so that you really don't have to care about the underlying infrastructure or the services required for running your application, and just make you focus on the code and getting that code into production, right? So everything from what's needed for running a good architecture, infra management, everything from CI/CD stuff to API gateways to security to observability, everything will be taken care of by the platform. Now, it's perfectly possible, like I said before, to do this without a platform like Choreo, right? So if you look at a platform like, if you look at like Azure, you basically have all the services you need to get your application up and running. But the thing is, you still need to wire it all up, right? So there are many organizations who are capable of doing this, but at the same time, there are lots of organizations who would appreciate some help in getting it all up and running, right? So if you're doing this with Azure, you can basically use these services such as, say, Azure Firewall, Azure API Gateway, Azure DevOps, Azure Log Analytics, Azure ADX, and all of these services. You can combine all of these services and build a platform for yourself. So that's one way of getting this problem addressed. Now, what Choreo does is it basically overlays on top of these services and creates an abstraction that is very simple and easy to understand for developers, right? So what we do is, behind the scenes in Choreo, we still utilize all the underlying Azure services, right? Some of it which I mentioned before, right? But what we do is create a layer of abstraction which simplifies everything. So developers don't have to think in terms of Kubernetes, in terms of API gateways, in terms of service measures, in terms of CI/CD or GitOps, or they don't have to think in those terms. They get a very nice and clean interface, an abstracted out and elevated developer experience for getting their job done, right? Which saves a lot of their time and effort. And this gives you like a very high level architecture of what I'll be showing to you in the next few minutes, right? So we have what we call as the Choreo architecture. And on the top left, you see here how we integrate with your code. So basically in the platform, what you really have to do is define your projects and write your code and commit it to GitHub and let the platform know that your code is ready to be deployed, right? Now, once that is done, Choreo takes your code, builds it, creates the Docker images, pushes it into the Docker registries, does all the image scanning, the code scanning, all of it, and deploys your code into Kubernetes runtime. So that is what you see in the bottom section of this picture. So the bottom section is what we call as the data plane. So the data plane is where your code will actually be running. It's a Kubernetes cluster, and you see certain abstractions, or rather the boundaries drawn as octagons. So these are basically for implementing or enforcing your application architecture, for creating the required boundaries. I'll talk a little bit more about that in detail when we get to the demo. And this runtime is cloud agnostic, so it can be run on Azure, it can be run on AWS, it can be run on GCP, it can be run on any cloud. So right, so all of these are is cloud agnostic. And all the quality of services that you need, like the observability, the observability tools, the API gateways, the service missions, they're all included. So as developers, you don't think in terms of those core concepts, but you think in terms of like this service should talk to this service, right? That's it. You don't think about the service mesh that should implement that. You don't think about the API gateway that enforces this. None of it, right? So you operate as a developer at a very high level of abstraction. And once everything is up and running, you of course needs all kinds of dashboards, right? You need so that's the top right section that I'm talking about now. So there's a built-in marketplace which allows you to discover all your services in your organization or in your project. The logs are presented through an observability dashboard. There's business insights provided, like how many transactions are made from which kinds of consumers, from which part of the world, likewise. We also have something called insights for CIOs, like how efficient is your engineering operation, how many releases are you doing, what's the failure rate, and how long does it take you to get a bug released into production, and so on, right? So this is basically a very high level architecture. And as I mentioned before, we utilize a lot of underlying Azure services to build this platform. So I've mentioned a few here, such as Azure Log Analytics, DevOps, Front Door, Firewall, AKS, Key Vault, and most of these things. And in the case of running the data plane on other clouds like AWS and so on, we use competing services from those. So that's basically how we have built it and how we utilize the underlying services into in our platform. So in terms of data, in terms of an organization, like you say, you are coming to use this platform, it's obviously multi-tenanted. So you come in and create your organization, and this shows you a cross-section of how your organization is organized, right? So we have the concept of an organization. So an organization can have multiple data planes. So you can connect one or more data planes into your organization. So data planes, as I said before, is where your code is actually running. So you can have, for example, data planes representing different regions of the world or different development environments such as staging and production and so on, right? So your data or your services are organized into things called projects. I'll explain to you, talk about that more when I get into the demo. So there's a concept called projects, where an organization can have multiple projects. Each project can consist of one or more components. So components are your microservices, your APIs, your web applications, your scheduled jobs, all of these things, right? So any one of these things can be a component within a project. And there's built-in environments as well. So out of the box, you get development and production environments, and you can configure any number of environments as you wish. So that's basically a very like a cross section of how things are organized in Choreo, and what it really means when you get into using it. So in terms of the demo, so that's basically the very high level and quick introduction into what we do. I'll talk a little bit about this demo application that I'm going to show you, that we're going to build. So this is basically an application, like a banking application, which gives you reward points from different vendors such as Starbucks or Target or Grubhub and so on, right? So the concept here is you're a customer of a particular bank, you log into this system, and the bank, based on your loyalty points and so on, they give you like coupons that you can redeem from different vendors. So this, you can go into this application and click on a particular partner or vendor of your choice and say, I'd like to redeem a coupon from this vendor, and they'll give you like $10 or $15 or whatever, right?
Noah, There's some
So
sort of
yeah,
static noise coming from your audio.
static noise. Okay, let's see what that is. Hello, can you hear me now?
Yes, it's better now.
It's better now.
Yeah.
Okay, I'll get it out of the AirPods.
Yeah.
All right, cool. So that's basically the concept of the application I'm going to demonstrate today. So I just drew up a quick architecture of the application, right? So what you see here is your web browser. So you will be logging into the application from your browser. And if you go down into this section, so as you can see, these microservices are organized into three domains. So at the inception, we have something called a rewards front end business domain. So that is dealing with the front end stuff, mainly your web application and these BFF services, if you have heard about it. Like BFF stand for back end for front end. It's like a data massaging layer, which creates the experiences you need for your application. And then on the back end side, we have two business domains. One is for managing vendors. So whenever you redeem a coupon from this application, it needs to contact with your vendor and make sure the vendor is notified and the vendor approves the transaction and all of the logic related to that. So as you can see, there is a webhook there as well. So once the vendor confirms your coupon, the system will receive a webhook, a confirmation through a webhook, which will internally go and update its database and so on. And the app, you will be given as a user, you'll be given a QR code, which you can then take from this application and go and redeem your coupon at the vendor. So this is the other domain that contains the business logic related to that. And finally, right at the bottom, we have a domain which I've named as a loyalty management domain. So this has services related to, actually just one in this demo, but it has services related to like managing the loyalty points of customers, right? So as you can see, there are different concepts here. So there is an external gateway which is exposing your services to the internet, and there's an internal gateway which is exposing services across business domains, right? And there are some services such as this QR code generator API, which is basically not exposed, which is only exposed within that domain. So outside consumers cannot consume it, only consumers within the domain can consume, right? So this is the application that we want to build, right? So let's basically now go and look at how we can actually build this application on Choreo. So to make things fast, I have built most of the application. I'm going to build one part of the application during this demo. So what you see now on your screen is the Choreo home page, what you see as soon as you log in. So I'm in this organization called Nuan Dias, which is my organization, and you can see all the projects in my organization here. So the projects related to this particular application are the top three, like the rewards front end, the external vendor management, and the loyalty management project. So this is how we abstract out the concept of business domains. So in Choreo, you don't really have to think of business domains, or you really don't have to think of boundaries. You just create a project, and underlying we go and create all the network rules, the API gateways and all of that related to that project appropriately, right? So you don't think in terms of core concepts, but at a project level, right? So these are the three projects. So these two projects, the external vendor management and the loyalty management, is kind of already built. So I'll go into this rewards front end project. So it has the the BFF, or the backend for front end API, already running. So what I'll do is I'll go and create my application and show you what it looks like and what happens behind the scenes, right? So there are some reports given over here. So if you want to create an application, you go into this create button, and then you can add your application to this project. So as you can see, you can add many different types like services, triggers, manual triggers, API proxies, webhooks, integrations, and so on, right? So in this case, I want to add my web application. So I'll go into here. I'll call this the rewards UI application and go to the next step. And from here, I need to point to where the source code of my application is. So it can be in GitHub, it can be in Bitbucket, or it can already be pushed into some container registry, right? So if I have such a container, I can directly point to it. So in this case, I'll go with GitHub. This is integrated with GitHub, so it allows me to browse my GitHub repository and pick the relevant directory of that, right? So this is my GitHub account, and this is my repository, and the branch is main, and the application in this case, what I have built is a React application. So I'm going to say React, and then I need to provide the build context, like where is this application hosted in GitHub. So this is my directory. So I'll pick that, and the relevant commands to build and run this application, right? So run build, and the node version used in this application is 16.15.0. So that's about that. And now we can go ahead and create our application. So at this point, this will go in and basically copy your code and create a component that is linked to that particular code repository. And in a few seconds, you should see the component getting created. Right, so you can see the component is created, and I moved it automatically went to the next step, which is to deploy this component. So we can also enable deployments on commit. I'll switch it off for now. And you can see here we have a concept called deployment track. So in many cases, developers have the need to maintain different branches and do different changes in different branches and commit them to, or rather get them to production, right? Sometimes in case of failures and so on. So we allow that kind of development through this concept called deployment tracks. So I can now basically go and deploy this application. So I can provide configurations from here, but I'll do it from another place. So I just go ahead. So at this time, we have basically triggered the deployment process. Now, as you all know, in any organization, once you have a piece of code written and tested locally, in order to get it deployed into any environment, there is a process. There is a process of scanning your code, for example, running the tests, building the images, scanning the images, right? And doing various kinds of checks before performing the actual deployment, right? So that's the normal process in any organization that's doing software engineering in the cloud, right? So this is actually what's happening now. So as you can see, the build steps are being presented. So everything is happening now. So as a developer, I didn't really have to worry about my Jenkins or any of those things, right? My image scanners, my image repositories, or anything like that, they're all provided. And you can, of course, as an enterprise, enterprises can plug in their own as well. But yeah, that's basically what's happening. So this takes a little bit of time for the entire process to complete. And as you can see, there are two environments called development and production. So these are the default environments you get. You can, of course, plug in your own. So there's this concept of building and deploying to the development environment, and then from there onwards, you promote to different environments, right? So that's the concept here. And you can inject different configuration variables into different environments and all of those things, which are normal requirements, right? So in any program, when you deploy, you need to provide environment variables and things like that. I'll do that in a minute to configure this application. So right now, the commits are happening to a GitOps repository, which is a separate repository than the source repository. and the deployment, as you can see, has been now successful in the development environment. So I won't go into the details of development environment. I'll directly promote this to production, so that we can go into the application quickly. So again, I'll ignore this configuration point at right now because I'm hoping to do it from some other place. So the promotion process is much shorter than the build process. Obviously, now we are taking the same image we had in the development environment into production. That's another thing that organizations are concerned of, right? Are you running what you actually tested, right? So we ensure that it is so. It's the same exact same image that is getting promoted. Now I can give a short URL for this application as well. So I'll call this Horizon Rewards. And you get a short URL for this, horizonrewards.choreoapps.dev. So yeah, that's basically that. So it's getting deployed again. Now, in order to, I cannot run this application yet because I haven't given the required configurations to it. So let me show you how that is done. So for any component, we have something called a DevOps section. So if you want to provide environment specific configurations, you can do it from this section. So I'll go into configs and secrets to provide the configuration, provide a configuration on the production environment, right? So I'll pick production because I'm for this demo, I'm not interested in dev. So as you can see, I can provide configurations from here. So I want to provide a file mount. So the config names, I'll call it rewards UI config. Mount path is a config.js file of this React application. And the configuration, I have it here. I'll just copy paste it from my other window. Okay. So this application needs its URL, its client ID, the identity URL or the OAuth service URL, and the API URL, the API URL of my BFF to talk to, right? So the API URL, I'll get it from my developer portal. So the BFF that we saw, that we talked about before, is deployed. I'm basically going into the developer portal to copy its URL. See, it looks like I've been signed out of the developer portal. It's signing me back again. Yeah. So this is the rewards backend. I'll pick the production endpoint of it, copy it, and paste it in this configuration here. Yeah, so that's basically it. My configuration is done. Now I'll go ahead and create this configuration. Now behind the scenes, what's happening is this is going and creating secrets in Kubernetes, or rather config map, right? So if I go back into the deployment screen, you can see that my production instance is restarting or rebooting with the new configuration that I did attached to it. Right, so might take a few seconds to reboot. Right, so the application seems to be active. Let's go and see if we can access this application now. So I'll open a new private window and see if we can get this application, access this application. Right, so this application is protected with Asgardio login. So Asgardio is another service we have in WSO2, which gives you identity and access management and custom identity and access management. So let me give my username and password. Okay, select class. Mukas. Okay, let's see. Okay, I'm through my authentication, and the application should load now. So this is basically the UI of this application. So it's a demo application, not like a production scale application, which we use for demo scenarios, right? And if I go into this section, this is where it allows me to redeem my rewards. So as you can see, I can pick on a vendor and then redeem the coupons, right? And so it gives me a QR code that I can now present to the vendor and get a value of $15 for my coffee, right? So that's basically that on the application. It's a very simple application built for demo purposes. So I'll go back into Choreo. So this application is up and running now. So I'll switch to a different component for the rest of the demo. So I'm going back into my front end project and picking on the BFF, the API. Now, so far we built the web UI. Now I'm going to show you the API behind the UI, right? So this is called the rewards BFF API. So it also has a similar deployment process. So you can point to your source repository and get this code up and running in your dev and production environments, and you can inject different configurations to it, just like we did in the previous section. And you can test your API. So we have a test console, like here. Since we know the spec of the API, we generate a built-in test client. So for example, this is the operation that there's the QR generation. So you can generate QRs for different texts here. So as you can see, we have in the response, we get an image of the QR of this text. So that's about the test. We also have a cool feature which allows you to interact with your API using natural language. This is still in beta. So instead of interacting with your APIs, through as a REST client, we allow you to send queries to it. So you can say things like get me all rewards, and type your queries in natural language. And of course, this is AI driven, so it sometimes works, sometimes doesn't. So in this case, it knew how to get it. So I can say things like generate QR code for text demo text. So this is natural language, and it knows automatically how to execute this, right? So as you can see, we get a successful response, but unfortunately this UI is only able to render text. It cannot render images, right? So but the functionality works. So that's about the testing part. And then of course, when you're building APIs, one common requirement is, now when you need to expose it, you need professional API management, right? So this is all built in, as you can see. So this is the section where you do API management. So it's automatic. You don't have to do anything manually, but you can go and change and tweak things if you want from here, right? So there's a life cycle associated to your API. You can publish it, demote it back. You can see who are the consumers of your API. In this case, there's one application. You can attach documents to it. Now, if you have any interest in monetizing this API, you can associate different kinds of usage plans. If you have security authorization requirements, you can set all those up here for your API, and do various kinds of other settings, such as in this case security settings like cost settings. You can do all of those things here. If you want to apply rate limits on your API, you can do those things here. So as I mentioned before, the idea here is, like, when you have any organization that's exposing an API has these requirements, but instead of thinking in terms of API gateways and things like that, all you do here is think in terms of your business requirements, which is rate limits or security type, right? You don't worry about gateways. They're all built in and transparent to you as a developer, right? So we'll go to the other sections in a bit, but quickly I'll jump into the observability section, which is again another interesting piece where whenever you're running anything in production or in any lower environments, you need a lot of insight into it, right? For debugging purposes, for understanding purposes, and so on. So this gives you a visualization of your operations. So let's see. Let's basically look at some stats for the past 24 hours. So you can see your throughput, latencies from here. You can click on these points and look at the individual requests. And you can see the logs appearing down here. You get a diagnostic view of what's happening, like the CPU, memory utilization, and all of those things as well from this observability section. Right? So similarly, you get the same kind of insight from this log section. So as I said, when developing on Choreo, you don't think in terms of setting up your log analytics system or so on, right? You don't think in terms of Azure like log analytics. It's built in for you. You just have to print your log and it will appear on the UI, right? So you can basically use different kinds of filters for these things as well. So that's about that particular API. Now I will switch to a different project. So far we were looking at the front end project. Now let's switch to the external vendor management project. So if you remember from this diagram, so far we were looking at things in this project, this domain. We are now switching to this particular domain just to show you some insights at a project level, right? What are useful to know. So this is the overview of this project. So if you go into this component section, you see the list of components, and another interesting part is the architecture. So this is another big problem that organizations have. Like they draw an architecture on, as I've done, in some piece of paper or whiteboard, and or some diagramming tool, and they give that spec to the development team. Right now, how do you actually know whether that is the exact architecture that was implemented? What are the network services? Are they as you intended it to be, or are they different? Right now, this is what we are trying to show here. Now if you go into the architecture diagram of this particular project, you can see, okay, there are 3 components, looks fine, but all these components seem to be exposed to the internet, right? But that was not the intention in the architecture, right? So if you remember, one had to be private, one of these had to be internal, and this one only should have been a public endpoint, right? But if I go into this architecture now, I can see there's all those things have been created as public endpoint. So this is derived basically from the underlying network, right? Based on where the packets go. So you can see how components interact with each other, and you can basically get a judgment of how well you have adhered to the intended architecture, right? So that's basically on that front. And we also have like usage insights, which is like business insights. So previously I showed to you like observability, which are things like logs and matrices. Now these are things like at a more high level, business level. What is your API traffic like, and so on. So you can look at this both at a project level, and if I basically close off this project here, it will now start showing me details at an organization level, across the organization, right? So let me pick the production environment, and it will show you like what's the traffic like for the past 24 hours, errors, error rate, latency, and there are different graphs here which help you get a picture of what's happening, right? What types of clients are using your application, what kind of errors you are receiving in the system, what's your API latency like, right? And which kind of devices, as I said before, various alerts for various APIs that you can pick on, different APIs from here. You can generate custom reports as well. So you can basically combine different kinds of metrics and download custom reports. So that's on the usage side of things. And similarly, we have insights on the delivery side of things, which is like how efficient are you as an organization, right? How efficient are you in terms of doing releases and so on. So this gives you an insight about all the components you have in the system and their statuses. Now if you switch into this DORA metrics, you get a sense of what's your deployment frequency like, what's the lead time for change, and various kinds of other insights, right? So that's basically on the delivery insight. So these are again useful to know when you're running a complicated system in production. So I briefly showed to you the developer portal before. So the developer portal is where you expose your APIs to outside now, or even to internal people now, right? Now, say you as an organization have a set of APIs, you want to expose it to um, different kinds of consumers. You can basically do that by pushing your APIs into a developer portal. So it gives you like the same kind of tryout functionality. It gives you the ability to view your documentation. It will allow you to generate keys for your applications and so on. You can also look at the register applications. So now, if I'm browsing this portal as a consumer, I can register my applications in here. Like this is the rewards application that we were looking at, right? Look at all the APIs it is subscribed to, and basically go and subscribe to new APIs if I want to. I can go and see the keys for my application. It's all built in, right? So you don't have to bring in additional stuff to get this all to work. They are all built in for you. So that's on the developer portal side. The developer portal is useful for consuming APIs, both could be from an internal or as an external consumer. So that's basically on that. And finally, we also have a concept called the marketplace, which is mainly used for internal discovery services. So everything you add in your organization is put into a thing called a marketplace, where you can filter out, search for services to consume, and so on. It also shows you the public endpoints that are allowed for you to consume. So that's basically on that. So this is what the marketplace looks like. So you can see things from my organization which I have pushed into here, and things outside my organization that I can connect to as well. And you can do various kinds of search and filtering on this based on various parameters. So yeah, that's basically what I wanted to show you all today. I hope it was insightful, and if there are any questions, I'd be glad to answer. Are there any questions? I don't see anything in the. Okay, so there are some comments. I can see some comments. Can we configure the output connections to services outside the cluster? Yeah. Yes, you can connect to connections outside the cluster. Okay, I mean from the pods to an external service like a database or an API. Yes, you can definitely do it. So you can connect to things like databases, third-party, public APIs, or anything like that. Can we incorporate a gateway like Istio to AKS? So not right now, but we have a built-in gateway which gives you all the API gateway functionalities, and there is a service mesh as well. So the service mesh is based on eBPF. It's running Cilium to be precise. At the moment, we can't replace our gateway with something else, but that's something we are looking at. In the future, it will be possible to do so. Right now, the APIs are exposed on our own gateway. Yeah, so those are the questions I have seen so far. If there's anything else, I'm happy to answer.
So I guess there are no more questions.
All right. So can we wrap up then, Azar?
Sure. So thank you so much, Nuan. Thank you for a wonderful session. It was really insightful. I hope our audience have learned something today. So thank you everyone for joining today, and we'll keep in touch and keep doing these sessions for you. So stay tuned. Thank you and have a good day.
Thank you, guys. Thank you. Thank you, Azar.
Thank you. Bye.
Bye.